right? The load can either be commercial, residential, or industrial, right? It can be at different voltage levels, right? And it can be of different configurations, such as a three-phase load or a single-phase load, right? It might be a 110 load or it might be a 220 load, right? But all of them is classified as a load. Now, how we get that from that generating point to the electrical or the customer, right? You would have covered in some other course, right? Generation, transmission, and distribution, right? So this module takes it from the point of the distribution transformer and to the facility and to the load. All right, so it looks at utilization. All right, we said the vast majority of electrical systems, right, operates between 110 volts to 230 volts single phase, right, or 220 volts to 430 volts three phase at a frequency of 50 or 60 hertz, right? Locally, our frequency is 50 hertz, while in America they look at 60 hertz and so on, right? And yes, you would have realized from your electrical machines and drives module that the frequency does affect the rotation of the device, right? For instance, when we're talking about a washing machine, when we're talking about our AC motors, right? We're talking about the simple shear that they use to shave, right? Or a clipper that they use to shave, the frequency do affects it, right? Any of you have been to out of the country before in a 60 cycle system, right, such as America, you'd realize when you are using an electrical shear that is plugged into the outlet, not a battery one, but one that is plugged in, you'd realize that it is silent, right? It runs silent and without noise. However, when you take that same shear and to use in our distribution network, our system, right, we realize that it makes a lot of noise and actually don't click properly, right? And this is because of the difference in cycle, the frequency which it is designed to use. So that's a critical part you need to understand about electrical equipment and when purchasing electrical equipment, right? So for instance, if you are the design engineer at your facility, right, you need to take these consideration in mind, the voltage requirement for the machine, the frequency requirement and the power requirement of the machine. You'll also look at the physical space and other stuff, but as it relates to electrical, that's what we'll be looking at, right? Also, these utilization networks, most of the time, are often classified as low voltage, although we have heavy-duty industry that uses medium voltage, right? But for the majority, uses low voltage applications, right? We talk about the larger installations, which are the heavy-duty installations. We talk about them operate at voltages between 6.9 kilovolt and 23.9 kilo, or 24, we talk to 24 kilovolts for different regions. So different regions will vary depending on the generators. Right? These networks are referred to as high voltage or medium voltage networks in some regions, right? And so on. Customers being primarily metered are required to purchase, install, and maintain their own transformers. So if we're talking about a heavy-duty industry, we are saying that these customers would definitely need to purchase, install, and maintain the transformers that so they use at their service entrance, right, to supply their high-voltage switchgear. And when we're talking about switchgear, we're talking about their distribution points, right, their panel boxes, their enclosures, all there and that, and so forth, right? Classified it as switch it further as we go along. All right, the components are electrical, yes. All right, so the components of electrical system, we talk about the conductor, switchgear, and loading devices, right? That's basically an overview. There are other components involved, but these are the main components. So most of the conductor to carry the electrical current, most of our switchgear to distribute to the different circuits, basically the distribution, and then the load is where what we utilize the electrical energy for, right? So for persons who forget what a conductor is, we say that the conductor is really the means by which electricity is transferred from one place to another, right? And please remember that the conductor is just the current carrying part of the cable. A cable is typically divided into 2 or 3 parts, right? We have the conductor, we have the insulation, and in some cases we have the outer sheet, right? So that the conductor is really what carries the current. All right. Typical conductors are made from copper. Yes, we do have aluminum conductors such as their service wire, right? They are made from aluminum, and most when we're talking about overhead, give me a second. All right, guys. So we said that the conductors are typically made from conductor aluminum, right? When we're talking about overhead cables, we talk about mainly aluminum type cables. Now, these cables are so designed to facilitate weather conditions and high tension conditions, meaning that under stress, because a lot of time they'll be running from the distribution pole to a stanchion that is on the consumer's house. As it relates to insulation of these cables now, they might be insulated using PVC, right? They might be insulated using a type of thermoplastic material, thermosetting material, because the thermoplastic is the PVC type, right? While thermosetting material is the type of material that is a combination of both thermoplastic and high temperature device. Now, what an example of this type of cable would be like your XLPE cables, right? So you like your XLPE cables, these would be a type of thermosetting material. And for persons who don't know what an XLPE cable is, it's really a tougher type of insulation, right? It's not as flexible as the PVC insulated cables, right? It's more rigid, right? And when exposed to high temperatures for a period of time, then it starts to degrade and crystallize, right? So that's a drawback in terms of using this thermosetting material. While the thermoplastic material or polyvinyl chloride (PVC) is subject to these temperatures for a longer period of time, so they won't degrade easily, and that is why we can use conduits in outdoor as well as indoor application, right? The typical temperature range, when we're talking about conductors or cables, we talk about 60 degrees, 75 degrees, and 90 degrees in terms of their temperature range, right? Now, operation of any cable at all above its stated temperature range will cause that cable to degrade over faster than necessary, right? So if you were to operate a 75-degree temperature cable at 90 degrees, and these are in Celsius talking, then it will start to degrade at a much higher rate, right? And this is why when we're talking about overloading the cables, remember when you pass a current through a conductor, it will produce heat, right? And if we're talking about passing more than the maximum allowable current through that conductor, then the insulation will start to break down, all right? Because it's designed to work at a particular temperature. Now, the different type of cables that we might use now for the incoming electrical service. So remember, we talk about the entrance, we talk about within the building and so forth. We talk about the triplex wire, right? For persons who don't know, this is the typical wire used for cable used for overhead installation. So this is where you have the two black insulated conductors, and we have the bare aluminum conductor. So it's a triplex, and it's typically used for 220 single phase, right, 3-wire situations where we have 2-phase and a neutral conductor. All right, so you will find that, and they come in various size depending on your design current, right? So they come in various sizes, guys. Now, one of the typical insulation used for our overhead cables, that's XLPE. No, not the XLPE, the triplex is our XHHW. Now, this type of cable is really our high heat resistance capacity, right? And it is used for wet or dry conditions. So you can use in rain condition, or you can use it in conditions that are dry. It's designed for that purpose, right? The temperature rating for this type of cable is approximately 90 degrees, right? So for those triplets that you see everybody using, right, the insulation type is really the XHHW type, right, which is actually designed for that particular type of use. Now, other conductors commonly used in buildings are like bus bar conductors. So we're talking about the bare bus bar in a enclosure, right? It can be of the riser main type, or it can be your regular distribution box, right? But true and in fact, right, these are also conductors. Remember, we tell you that the conductor is what carry the current, you know. So the conductor can be a bar as well as it can be a cable, right? These are usually copper or aluminum type bus bars, right? And are actually tucked away in an enclosure, typically a trunking type enclosure or a metal clad enclosure, right? Metal clad meaning the galvanized boxes that are, should say, colored gray, right? Most of them come in gray type for installation purposes, right? These may be used where larger conductors are required, as the bus bar trunking is often physically smaller. So rather than have this whole heap big SWA cable or large size cross-sectional area cables, right, running, they actually use the bus bar trunking, right, for aesthetics purposes. All right, so it's just some bars, right, rather than having the 3 cables in a SWA or 4 core SWA cable. They just have the bus bar trunking, and it look much better. All right. So when we come to the switch gear, right?
Sorry. The bus bar trunking you talked about, is that aluminum metal one, like?
Yes, but the bus bars are insulated from the metal by either ceramic material or thermal setting material, right? So you either use ceramic or thermal setting. No, the thing about the bus bar trunking, you know, is that when tightening your lungs and so forth onto them, right? And when tightening those cables onto them, you use a lug and not on board. Now, one thing you need to understand is that the torque requirement of these bus bar, because of the high current we expect for it to carry, then you have to ensure that these cables are affixed to it properly. All right. If you want to see what one look like when you go to the power lab today, that's entering the power lab to your right. There's a bus bar. There's a bus bar trunk in there, right? That you can actually view and see how they make the connections to the bus bar, right? Continuing. All right, manual control relies on human intervention. So we're talking about how to control the bus bar or switch gear, right? We have two methods. We have the manual method.
Excuse me, sir.
Yes.
I'm not clear on the bus bar. Is it pole mounted or it is located on a building?
Repeat.
The bus bar, is it pole mounted or it's located like
it's in the building. So we're talking about in the building. Remember, we're talking about this in the building now and the switch gear. No, rather than have a large cables, distributing power to different sub panels, right? You might have a bus bar setup, right? And typically, what it is being used for in today's environment is when they are doing these apartment complex. Now, the apartment complex, remember you're going to have several meters, right? Because we're talking about an apartment complex, so you have different residents on it. One way is to create a bus bar chamber, right? What is known as a bus bar chamber. Now, the bus bar chamber is so designed that you have copper bars running from one point to the next that are insulated from touching the metal enclosure, right? So it's in an enclosure like a panel box, but it's much larger than the panel box because we're talking about probably 10 meters, we're talking about probably 15 meters, right? So rather than have a whole heap of different meter socket mounted on a wall, right, they create what is known as a bus bar chamber. Now, with the bus bar chamber now, all they do is really mount the jacks or the sockets for the meters, right? So JPS would come now, power the bus bar. So from your service drop wire, that's a wire coming from the pole to your potted, and then from your potted connection to your bus bar chamber, and the bus bar chamber will distribute to the different meters, and then from the meters you'll have the connection to the different residents within the building, right? So true and in fact, when JPS come, all they need to do is just go to the metering room and they can just read all the meters one place and have all the meters scattered over the place, right? So this is really one application of a bus bar chamber. Right? There are several applications. In an industrial setting, you'd have a bus bar chamber, right? And then all the different sub-circuits are connected to that bus bar chamber through a breaker, right? So we're talking about large utility rooms, and they are built from metal enclosures, right? They are built to specification, a lot of these bus bar chambers, right? Compared to your commercial or your small commercial or your resident where it does have 1 meter box and one distribution panel in most house, right, where you connect from that meter box to your panel box and then from your panel box to the different sub-circuits. Yes, your panel box do have bus bar on them in them because you see those little sprung that you connect your breakers on, those are also classified as bus bar, right? So you're not going to see a bus bar by itself. To answer your question, you're going to see it in an enclosure. All right?
Yes.
And 90% of the time, the enclosure is made from galvanized or metal material. All right?
Yes, sir.
All right. So those are really different types of switchgear, right? Your bus bar chamber, your single phase panel, your three phase panel, these are all just different types of switchgear that they use. Now, in some industrial application or some commercial operation, these switch gears can be operated remotely then, right? So that, such as when JPS use their automatic reclosures, right? These are set to operate remotely, right? Or they can operate them manually, which is local, right? So remote application of these switch gears are would be like when they have like for instance contactor block. They can have a PLC type device that can be connected locally, right? So when we're talking about remote operation, we're talking about some form of integration of control methods, right? And this is why as how we the degree is now designed for you to get a little of everything, because we realize that in Jamaica's society and the rest of the world, we're talking about engineering, we're talking about having a person that is capable of doing a system by themselves, or 90% of that system. So they need to have a wide exposure to control engineering, they need to have an exposure of power engineering, they need to have an exposure to a little mechanical engineering and so forth, right? So to properly utilize that person in an industrial setting, right? All right, so we said the automatic switching. So switching function may be based on protection characteristics, such as I tell you, your reclosers in your substation, right? These are normally used for protection purposes. If there's a fault detected, it will cycle out and then it will cycle in, right? And depending on its setting, it might be set to cycle twice or 3 times before it's automatically locked out, right? And then they would have to go and manually look for the fault, patrol the line, look for the fault, and then they'll go now and call control and tell them to close the recloser, right? So this is really mainly, most of the time it's used for protection purposes, right? Most system that has an automatic lockout mechanism or switching mechanism is mainly for protection purposes. All right, load devices, right? So these are really the final type of devices in a facility. So we're just doing a broad introduction now. We can't look at every device, guys. We'll never finish. Electrical is so wide, even in a facility that we can't look at. We have to bunch them, right? So we're talking about load devices now. We said these are the final components of the electrical systems, right? These convert the electrical energy to other forms, such as, example, I give you light, give you heat, I will give you movement, such as motors and so forth, right? Light fittings, we talk about luminaires in a building. So rather than have single lights, we have a fixture with a number of single lamps in it, right? Whether they be LED or fluorescent, but we call them a luminaire, right? We're talking about motors, we're talking about electric heating units and so on, right? As well as power conversion equipment, right? Which converts from one power to the next, right? Normally, these conversion, as we say, is done within the appliance or the load unit itself, right? So that's a conversion of power. Give me a second. All right. Now, regulation recommends that every consumer installation should have a means of isolation, whether it be the IEE regulation, the NEC regulation, or our local regulation. But it states that each consumer, right, and we're talking about both industrial we're talking about commercial, and we're talking about residential, right? So don't think as consumer as just your home, right, or a small installation, right? Whether it's small, medium, or large, the regulations state that it must have a means of isolation, meaning it must have a main circuit breaker, right? Now, that circuit breaker can either be in an enclosure, it can be in a panel box, right, or it can be in a plus main type of three-phase unit, right? That is where it, so we never tie that incoming service wire directly to our bus bar, right? It must have a means. So like your bus bar chamber, it will come into a main circuit breaker. Normally it have a handle to operate because of the current rating. So we're talking about 200 amp, it might have a handle, right, attached to it to operate the breaker because of the current carrying capacity of that breaker, right? So it will come into that breaker, and then that breaker would be connected to your bus bar chamber, whether by links or the bus bar it have a section for you to mount that breaker and connect it or screw it down to the bus bar, right? So you have different methods. Now, one such I can tell you about is like your power line panels, right? Some power line panels will come with a plus main, right? Meaning that when you go to the store to purchase it and you ask for a plus main, you will tell them the size main, right? So we're talking probably a 200 amp breaker will come in the and is already connected to the bus bar, right? All you would need to do now is actually buy your power line breakers. And for persons who are not aware what I'm talking about, power line breakers are the ones that you screw down to the bus bar, right? So the power line breakers, they don't clip it in. It's not a plug-in like your typical residential distribution box, right? We're talking about one that you have to screw down, right, and ensure that it is screwed down properly because of the type of application, right? And mainly they are used in industrial applications, right? So you don't want the breakers to be moving or anything like that. You might have a lot of vibration and so forth, so you buy a power line panel. One thing to note that the power line panel only come in certain sizes, right? So you will not get a power line panel smaller than 24 way, right? Unless you get it custom built, right? So if you go to the store to buy and ask for a power line panel, you get a 24 way power line panel, right? Compared to that of so if you go somewhere and probably see a 12 way power line panel that's custom built. Yes, and we do have places out here that custom build power line panels, right? So we do have some skilled persons in Jamaica, right, that have businesses that operate and sell these devices and equipment.
Sir, you can go over that one more time. The power line panel, what is the other one?
All right, the power line panel is really, it's similar to your home distribution panel box, right? So the look is the same. So if you were to buy a 24-way panel at home, and you buy and look at it, and you buy a 24-way power line panel, they look the same outside, but inside is where the difference is, right? The regular 24-way panel, the breakers are plugged in, right? So it will use a plug-in type breaker. It's not screwed down. While in the 24-way power line panel, right, if you ask for a plus main, it will come with a main breaker. If you order it without a plus main, you will definitely need to buy a main breaker, right? Now, when you buy the power line panel, you would buy power line breakers. The power line breakers are so different in that you have to physically screw them down, right? So they come with a sprung to the back of the breaker, right, where you normally that part would be plugged into the bus bar. There's a sprung there that you have to screw down to the bus bar.
Is there a reason why you have to screw down that one?
Yes, because of the application. So when we're talking about like some industrial applications where we're talking about vibration, we have a lot of vibration, we have a lot of moisture and all of that. It secures the electrical connection, right? So yes, the plug-in, you have electrical connection, but the power line panel secures, because it's not necessarily the current, because you can get a power line breaker as 20 amp, you can get it as 15 amp, so it's not the current that determines if the panel is a power line panel, right? But the application. So most industrial applications will have a power line panel if you have a lot of activities in the panel room and around the panel room, such as vibration and all that. All right? All right, moving along. Right, we're looking, before we can move on to anything else, we are going to be looking at the different types of drawings, right? Yes, we are engineers and aspiring engineers and practicing engineers, but we still need to have an understanding, a good understanding of the different types of diagrams, because a lot of time persons kind of mix up these diagrams. Some of them are close, but they are different in some way. Now, why do we need diagrams, electrical diagrams, right? We use them for communication of technical information, right? So rather than me have to sit here and explain all of this to you, right? And they say a picture is worth 1,000 words, that's basically the application of a diagram, right? So a diagram is worth 1,000 words, because when you learn to read this diagram, and I send you a diagram, you know that this is a motor that is installed here. You know that it's a 3-phase motor. You know that it's a single-phase motor. You know that the type of installation based on the diagram or the diagram of a workshop, you must use flexible conduit to connect to the motor from the isolator and all these things, right? We'll reach to different systems in the application like exponent and flexible conduit, right? But yes, the diagram is very useful, right? The type of diagram to be used in any particular situation is the one which most clearly communicates the desired information, right? So whether you're going to have a schematic diagram or a layout plan or that, no. If you want to show the layout of the facility, we definitely have to have a layout diagram, right? And it won't necessarily show the interconnection between the devices. So let us look at the different types of diagrams, right? We talk about the first set, which is a site plan or layout drawing. Now, what is a site plan or what is a layout drawing, right? These are scale drawing, so they are drawn to scale. So once you look at a site plan, right, these devices are drawn to scale diagrams based upon the architect's site plan, right, of the building, and show the position of the electrical equipment which is to be installed. So they're going to show you where the panel box must be, where you must put the electric heater, and so forth, right? So, and again, we say the electrical equipment is identified by a graphical symbol, and this is why we need to learn the symbols when we were studying from year 1 coming up, so as to be able to read these diagrams. Now, so this is an example of our layout or site plan, where you will see the switches, the lights are positioned, right, whether it be a typical ceiling light, whether it be a fluorescent lamp, whether it be a wall-mounted receptacle, whether it be a duplex plug, as shown here, and so on, right? Or a single pole double throw switch. That's basically what this is. So it's a 2 position. So you're able to turn the light, this light on from this position and from this position, right? So from this position, we're able to control this light and from this position as well, right? While these parts will have a single lighting switch for one position, all right? And here we see our electrical panel in this room, right? So this is our panel room, right, tucked away. All right, so that's basically an example. Now, as fitted drawing, what's an as fitted drawing, right? When the installation is complete, remember, first you're going to get this, but you might have some changes, and this is when you need to submit your as fitted diagram to the architect so they can make changes to the site plan, right? So your as fitted diagram will normally be you marking up this diagram and say, listen, I wasn't able to put this light here. I had to turn it this way. So you might make a marking on the site plan and you resubmit it to the architect and he makes his changes, right? So it actually indicates the final position of all electrical equipment. Right? Distribution cable, yes.
Actually, the as-fitted drawing is the same thing as the as-built drawing?
Yes.
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 Same thing.
Same exact thing. How the device is installed. Right? The same exact drawing. Distribution cable route, right? On large installations, there may be more than one position for the electrical supplies. So we're talking about a multi-story building, right? And again, a lot of time, and I can tell you from experience in UTech, right? A lot of time them lost these diagrams and people and persons just bury cables all over the place, right? And then lose the route where the cable is, and then them have to create new cable routes and abandon the old one and all of that, right? But it's good to have a distribution cable route because it shows you in large installation where the underground cables lie, right? Mainly the underground cables because you're able to see the overhead cable positions, right? But hidden cables, it's definitely good to know where they are so that when you're planning new or addition to your installations, you have a good idea where to avoid and where the cables are. Right? The site of the submarines taken by distribution cable may be shown on a blank copy of our plan. So what you will do is actually give him your as-fitted drawing, right? And then you will add that to another diagram that accompanies the electrical plan, right? And that would be to show your distribution routes, right? Your block diagrams now. Your block diagram is, I will know, everybody should know at this point what a block diagram is, right? Simple diagram in which various items or pieces of equipment are represented by a square or a rectangular box, right? See, that's what it is. The purpose now of the block diagram is to show how the components of a circuit relate to each other, right? It shows you the flow of the circuit. So it shows you that the supply is connected to the distribution box and show you where, and show you probably a lathe in a square is connected to a particular distribution box and so on, right? So it's very useful to show the flow of electrical components in a drawing, right? I'm going to show you an example of a block diagram where we show you this is really a temperature control system, a space heating control, where we show you the room rheostat. So we are saying that the controller is the central unit, is the brain, and it will control take all of these signals in and control all of these other devices, right? So it takes in the signal from the room thermostat, from the cylinder thermostat, from the programmer, and it's used to control the pump, and show you the flow out the fuel control valve onto the boiler and so, right? So it shows you the flow of the interconnection between the components. All right, the wiring diagram, which is an diagram that we are or should be familiar with, right? We talk about, it shows the detailed connection between components or items, right? So rather, unlike the block diagram where they show you the flow, this will show you the connections, or the detailed connections between them. All right, they do not indicate how a piece of equipment or circuit works. That's basically the circuit diagram will show that, but or rather the connection. The purpose of the wiring diagram is to help someone with the actual wiring of the circuit, right? So for instance, you get a circuit to wire, right? It will help you if it's your first time. You would have learned how to read a wiring diagram, and then you are able to read this diagram and make your connections. All right, and so this is actually, so internally in the room rheostat, it shows you the configuration, what is connected to what, and it shows you that it comes to this point, terminal, and so forth. It shows you the cylinder. So it's the same diagram as this, you know. It's the same diagram, but now we are showing you the connection between them. You see the cylinder rheostat. This is actually your controller, see, in the middle, right? And the cylinder rheostat, thermostat, and you have the room thermostat and so forth. If you were to go here, say cylinder, thermostat, room thermostat, it shows you the different connections and how it's connected to the controller and so forth, right? So it shows you the detailed wiring of the circuit, right? So it is telling you that terminal 1 right here should be connected to the gray terminal in the controller, right? And the gray terminal in the controller must be connected to the gray of the water control valve and so forth, right? So I give you a detail. Now your circuit diagram now is what basically used, and this is what we are familiar with, and it shows you how your circuit actually works. So to explain the operation of a circuit, we normally use a circuit diagram. All essential parts are shown and connections are represented by their graphical symbol, right? And the purpose of this circuit is to help our understanding of the function of the circuit, right? So this is basically the same diagram, you know, the same space heating control, but now it's easier to look at this diagram and tell you the flow of current through the circuit, right, and how the circuit works, right? So it gives you a much clearer understanding of how the circuit will work. And what is what's happening? So we're using the same diagram throughout, you know, but we are showing you how differently you can represent it and the different information that it gives, right? So it shows you the input line, right, and will show you the switches and so forth in the thermostat, the resistor. This is wired back to the neutral, right? Yes.
So this one will be what, the schematic?
Yes, in a sense, yes. This is the circuit. Repeat?
The one before this?
No, the one before this is the wiring diagram.
Oh, the wiring diagram and schematic.
Yes. So you realize that it shows you the internal connection of the devices, right? So it's very difficult. If you were to explain this to somebody in terms of the operation, they're going to have a lot of problems, right?
Okay, sir.
Yeah. While if you were to explain the operation now from this circuit, it's much easier, right? Because you can see the flow, the input, right? Current, right? With the temperature sensing device, right? Once the temperature will vary, causes this switch to close, and then this switch is connected to your motor and so forth, right? So it's easier to explain the operation here than from this diagram. And No, this is where the schematic diagram come in, yes. And the schematic diagram is very close to this diagram here, your circuit diagram. They are very close, right? I'm going to show you. This is your schematic diagram, while this is your wiring diagram. So these two diagrams are normally used interchangeably, right? Because we can use this also to explain the operation of the circuit. Right? So the schematic and the circuit diagram are very similar in nature, right? And this also helps with the understanding the working operation of the circuit, right? So the schematic and the circuit diagram are similar in nature. They do this, they carry the same purpose in terms of understanding the function of the circuit. And that is why when you said a while ago, I say yes, that they are very close, because in truth and fact, they are very close in terms of their operation and how they are drawn. All right, the freehand or working diagram. This is where you actually make a sketch. A lot of time before we start work, right? We don't have the time to go on. For most engineers, including myself, right, we're going to set up a control circuit, we're going to sketch it, right? So we call it a freehand diagram, and we'll create a sketch, and then afterwards we'll go and create our formal drawing, right? So it's basically known as your working drawing, right? And it's made just for you, right? You use that sketch to produce your work, right? So you actually use it to see what you are to do next and so forth. Now your working or a freehand diagram might be similar to your schematic. Is just a matter of sketching this diagram, or is a matter of probably sketching your wiring diagram, right? So your freehand diagram may or may not be your schematic diagram, your circuit diagram, or your wiring diagram, right? It's just what you use to produce a circuit. You can rub out most of them pencil, so you can fix, right, and make corrections so that you can use your final drawing, right? So that's why it's classified as your freehand diagram. Now, and this is really an example of a freehand diagram. It's not hand sketch, but it should be hand sketch, all right, to take, right? It does show you how you will mount a device to a particular hollowed wall, right? So it's basically how a spring toggle clamp will work when used on drywall or wood, right? So here, this sectional installation is hollowed, right? You bore it hole, you push through it, and then the spring tension will release and put the clamp into place. All right. All right, so we have done our diagrams, and now we are at the actual building. So now we need to look at this in a little bit more detail. So first we look at our distribution transformer, which is on the pole mounted here, right? And we'll show you the connection to the neutral and to the hot line and so forth, and the fuse link, and the transformer itself, and the pole. I will show you the ground going down on the pole and so forth, right? Now, from this point where your service is connected to your pot head is known as your service drop, right? So this is your service drop from your connection to the JPS port to your service cap or pot head, right, for most persons, is considered your service drop. Now, there are calculations that you can use to determine the size triplex. So it's shown here is our triplex, right? And this is what we'll be looking at our tutorial, how to calculate the size of this wire, as well as probably the size of the wire from the service cap to your meter socket, and from your meter socket to your house. Now, there are two types of installation for this. It can be your overhead, that's from your service cap to your home, right? So from your meter to your home or your resident or your building or your facility, it can be an underground or it can be an overhead connection, right? And the two will vary in that if you are talking about overhead, you're talking about another connection of triplex from another service cap. So it won't be from the same service cap because you have to come into the meter socket and out from the meter socket to the facility, right? So it will be from another service cap to the facility if it's overhead. If it's underground, you are going to have the cables, right? So you're going to have conduit and whatever going RSWA from the meter socket to your distribution box, right? So, and that will be buried underground, right? Now, one thing to know that when you are burying cables, right, you need to have the cable at least 18 inches underground. You need to have at least 6 inches of refined material that is free from debris, that is free from anything that will puncture the cables or anything like that if you are using SWA or even if you're using conduit. No, one, and that is why they use sun, right? Because the sun would have been sieved and all the debris and all the anything that can cause damage to the conduit or cable is removed, right? So you put a layer of sun at least 6 inches, right, and cover on to ensure that if somebody is doing some excavation, they are able to come across a bed of sun before they reach the cable, right? So it's really to protect the cables from one person. And this is why you need to have the cable route, because if you are using a backhoe, right, that's what they use rather than manpower. When the backhoe make one scoop with the bucket, right, it basically gone below the desired effect and bust up any cable or any pipe or anything like that, you know. So again, that's why it's best to have your cable route diagram. All right, these are some clearance measurements for overhead service line. All right, so if this is your utility pole, we're talking about a road where we should have a clearance of at least 18 feet, right? If we have a walkway, because you realize that the walkway should have at least 10 feet clearance, we must have a 13 feet clearance above any surface roof, right, and so on. So a swimming pool will still have 18, right, and 10 feet away horizontally. So we're talking about the measurements, allowable measurements for all of these installations. So you realize that for flat roof, this measurement will be different because this is for the pitch roof. If the roof was flat, we're talking about this distance that will be from here would be added to the 3 feet for like your slab roof and so forth, right? So that's really for protection purposes because on a pitch roof, water will not settle. However, on a flat roof, you may have water settling if it was actually bordered around. All right? Now, earthing system in our installation. And again, we're just going to look at it briefly because if we can spend a whole semester looking at earthing and the amount of calculations involved, right? And it's all metal work associated with electrical apparatus and systems termed exposed conductive parts. So we're talking about all metal work and they are known as exposed conductive parts. For example, include conduit, trunking, and the metal casing of apparatus, right? So we're saying that all of these metal parts should be bonded to earth. Now, all metalwork liable to introduce a potential, meaning say once the phase conductor can come in contact with that metal, right, we need to bond it to earth, right? So we need to take it to earth potential, right? And these type of earth or conductive parts are termed extraneous conductive parts, right? Examples are gas, oil, and water pipe. So like all of those non-electrical metal parts, right, have to be bonded to earth. Now the process of bonding them is called the equipotential bonding, right? Meaning that we are carrying them to one potential, which is earth potential, right? So all your galvanized pipes in your home, right? All your any metalwork part of the building that is exposed or can become live, right, should be bonded to earth, right? So again, all parts of our electrical installation, once metal, should be bonded to earth, right? That's basically what it is saying. Now, conductor types used to earth. Now, if you are talking about your service conductor, we also can calculate the size of your earth, right? Typically, it what electricians or engineers or technicians will do is to size the earth conductor of similar size as the phase conductor, and that will take care of any calculation, right? But however, for most applications, like, all right, for instance, you're using a twin and earth cable. All right, you might be using a 2.5 twin and earth cable. What you realize is that if you were to look at the specifications of the cable, the two-phase conductors would be 2.5 and the earth conductor will be 1.5, right? So that what that is saying is that your earth conductor can be one size less than your phase conductors, right? But to make just to be safe when we are doing our installation, we normally select the earth conductor to be of similar size as the phase conductor. And that is when we are using single core cables, all right? That's when we're using single phase cables. All right, so we're going to look at the different types of earthing system. These systems have been designated in the IEE regulation using the letters T, N, C, and S. So for other type of codes that exist, such as our NEC and JS21, these are really derivation of the IEE regulation, the Institute of Electrical Engineers regulation. Now we said T is tier in this sense, meaning a direct connection to earth. So once the code have a T in it, we are saying that there is a direct connection to the mass of earth, right? Once we see N, we have a neutral, and then we see C, there's a combined combination. Where to look at the combination S, there's a separate earth provided, right? When these letters are grouped, they form the classification of a type of system. The first letter is such a classification, denotes how the supply source is earth, right? So your first letter will tell you what the utility company provides, while the second letter denotes how the metalwork of an installation is earth, right? So that's such as the metal pipes and water pipes and so forth. The third and fourth indicate the functions of the neutral and protective conductor, right? So we look at some examples of these. A TT system has a direct connection of the supply source to earth and a direct connection of the installation metalwork to earth, meaning that the metal conductive parts in a building is directly linked to the earthing electrode. Or, right, So an example is an overhead line supply with earth electrodes and a mass of earth as a return path, right? Now, a TN-S system, right? So the TN-S system has the supply source directly connected to earth. The installation metalwork connected to the earth neutral of the supply. So we're going to look at them in diagram now. We're just telling you what the wording mean, right? Via the metal sheet of the supply cable. So like for this type of installation, the metal, the supply cable might be a SWA cable, and we are saying that the source and the neutral is connected via that metal sheet, right? And the neutral unprotected conductors throughout the whole system performing separate functions, right? So they are not tied in at any point. Cable sheet earth supplies, which is a TS-S system, right? We said the neutral and protective conductors are separate throughout the system, right? The protective earth conductor is a metal sheet and armor of the underground cable, right? So remember, so our underground cable going to be like our SWA and so forth. And this is connected to the consumer's main earthing terminal, right? So we have to connect it directly to our earth rod that is driven in the ground. All right. So these are basically what we're talking about, the diagrams. It's much easier to understand than the wording. So what we are saying is that for this type of installation, we do not provide an earthing electrode, right? So the TN-S system does not carry an earthing electrode. However, there's an earthing terminal, so the earth is provided. We rely on the earth coming from the supply company, right? The entire system. So if the earth of the supply company fails, then our earth bonding and our earth will also fail. All right. The TNCS system, right? The supply cable uses a combined protective earth and neutral, right, at the supply intake. So we have a combined protective earth and neutral, right? So they are combined, right, at the supply intake point at the consumer main, right? So this is the type of system that we're talking about. So right here at the consumer main, right, the earth and the neutral are tied in, but no earth is provided by the supply company, right? Or by an earthing rod. All we have to do is rely on the earth neutral that is being supplied by the company itself, right? So we don't actually drive an earth rod in this system, right? And this system is really not our system. We'll soon see what our configuration is, right? And we'll talk about the TT, no earth provided supply, meaning that you would have to provide your earth, right? So they don't send an earth to your house, right? Even though their system is earth bonded, so they supply a neutral earth, but they don't supply a separate earth. This type of supply more often found when the installation is spread from overhead cables, right? So like our supply system for overhead cables from JPS, right? This is the type of system that we will use, right? The supply authorities do not provide an earth terminal, and installation circuit protective conductors must be connected to earth via an earth electrode provided by the customer, right? So this is what we are talking about now. On JPS side, they would have earth and bonded their earth to their neutral to keep their neutral at zero potential, but they don't supply a earth to us, right? So what we have to do, what we are getting is a live conductor and an earth neutral, right, conductor, but we have to provide our own earthing system, local earthing system, right? So in case the company loses their neutral earth protection, then we are also protected at the consumer residence. So at the facility, you have to drive your 5 feet earth rod, right? So you buy a copper earth rod or an aluminum earth rod. You'll drive it, you'll connect from your earth rod to your earthing terminal, and then link from your earthing terminal to your neutral terminal, right? So this is the link from your earthing terminal in your box to your neutral terminal, right? And then you will also earth your current carrying services such as the water and gas pipes. All right, so this is the type of system, guys, that we use locally, the TTA supply system, earthing system, right? And in most countries that they have a lot of overhead cables, this is the one that they use, right? Remember, on the supply side, their neutral is tied in like every other pole to earth, right? So like every other pole, they will tie in their neutral to earth to keep your neutral at zero potential. Good? The distribution panel. The distribution board is where the electrical supply is distributed from within the building, right? The main supply cable comes into the board and is distributed to the breakers from there to all the circuits. Example, your lighting circuit, your plug circuit, your water heater circuit, all of your control circuit, your fire alarm circuits, all of these circuits will be powered from your distribution panel. And again, I said the distribution panel plays a very important part because it houses your means of isolating all of these circuits. It houses your circuit breakers, right? Whether it be a single pole circuit breaker, a double pole circuit breaker, or a triple pole circuit breaker in the sense of a three-phase system, your distribution panel will mount all of those breakers, right? Now, your panels can either be supplied as single-phase panel or three-phase panel. What's the difference? We know that in a single-phase system, what we have learned from so far from year one coming up, right, is that a three-phase system of three live wires, right? It might be a three-wire system and a four-wire system will have three phase and a neutral, right? In a single-phase system, for our distribution network, we would have a two live, right, two phase, and a neutral, right, three-wire system. So this is basically how the panels are designed. A single-phase panel will have two bus bars for carrying current, while a three-phase panel will have three bus bars for carrying current, right? It will also have an earth terminal, and it will have a neutral terminal. Now, most panels in current time, meaning present, right, most panels will come with a connection between your earth bar and your neutral bar, right? It's still good to link the two with cables, right? So we don't rely on that, but we still link our supplies with cables. It's all right. Surface mounted, flush mounted, or floor standing cubicle switchboard. So what we are saying is that your panel or distribution panel can be surface mounted. It can be flush mounted. That's when we have to chop the wall or cut out the drywall and install the panel. Or it can be floor standing. Now, the floor standing is what you'll find in large facilities, such as UTEC and some other facilities. You'll have a standing cubicle, right? Selection criteria will be based on your current carrying capacity and the number of circuits that you can connect in the panel. For example, you can buy an 8-way panel, a 12-way panel, 18-way, 24-way, and such, right? So then that will determine the number of circuits that you can connect. No, so we'll show you an example of this panel, which is really on your, this is on left, right? This is your surface mounted or flush mounted type panel, right? Where we have our main, this is our plus main breaker here, right? And we have our individual breakers, right? So probably this is a power line panel. We can't see because we have to be able to see inside the panel or the data on the sheet, which you can't see. Now, this is our standing cubicle switch gear, and inside these switch gears are bus bar. So you'll have bus bar that the cables will either come into the top of the switch gear and go to the different circuits, right? So these are our standing so for this switch gear, your main disconnect is shown right here where you have the angle to disconnect all of the different cubicles, right? So once you switch this in the off position, all these cubicles will go down, right? So they'll and sometimes the cubicles are so designed that they can take the cables from buried cables from trenches, right? So it will fit over the trench, and the cable will be travel to the bus bar and is connected, right? And then the bus bar will lead to the breaker, and then out from the breaker to the individual cubicles, right? So that's basically how the cubicle connection will work. All right, we're talking about panel mount height, right? We talk about this disconnect enclosure, right? 6 feet 6 inches, right? No, should be your minimum working space above it. So then we need to mount this at least 6 feet from the finished floor, right, to the top of the isolator, right? For this distribution pole, we're talking about minimum space to be 7 feet, right? So we can mount this at least 6 feet 6 inches and so forth, right? You will not be violating any rule if you were to mount it 6 feet 6 inches to the top of the breaker, so you're able to work comfortably without have to be standing on access equipment, right? So it's very critical when you are mounting panels. Also, it allows a person to easily disconnect supplies in case of emergency. If you put it out of reach, them just can't reach it. And them have to go run for ladder. In case of emergency, them have to run for stool. Them have to go try find ladder for go climb up to be able to disconnect. No, they should be comfortable to disconnect the breaker that is at the highest point, right? So they should be able to disconnect the breaker at the highest point. Just give me a second, guys. All right, sorry about that, guys. All right. So our mounted height is really critical when we're talking about panels. You should be able to comfortably disconnect your breaker at your highest point, right? And so we have shown an example of a typical commercial and industrial distribution, right, where we have our main coming in and we have a main switch, right? So this is like a subdivision or multi-story, where this might be the separation of a floor, right, where it's said to load B to load C might be a different floor, right, and we have a sub-main to a sub-main panel here, right? So this is one type of arrangement that you can have, right? So it would come into our main switch, or this would be our bus bar chamber. Our bus bar chamber will be connected to our different isolators, and then we can isolate the different panels. So this might be supplied to different sub-panels, right, in a single story layout. For this, in terms of multi-story layout, now we're talking about apartment complexes that are about 3 or 4 story. We're talking about our riser mains, right, our bus bar risers that will run alongside. So when you talk about this type of installation, a lot of time the utility room will be in the same position right throughout, right? So it's just a matter of your utility room being above the lower utility room for easier access, right? So when it goes to the other floor, it's just a matter of taking it to your different consumer units, right? Which is basically your distribution panel box. Because in every installation, you know, you would have to have a panel box in every dwelling, right? So you can have a panel box and it control the entire floor. That don't make any sense because I should be able to disconnect my supply, right, without disturbing the other customers. The other customers should be able to disconnect their supply without me disturbing them. And this is basically in a situation like a building where we have different, it can be a building where we have different floors that deal with different aspects. Each floor should also have their means of isolation, right? So they'll have their consumer or their panel box that disconnect that particular floor. Very critical when we're talking about multi-story building. This is something that we have to plan for. And in most of these cases is where we have our cubicle type bus bar chamber, right? We're talking about our standing distribution point. Because what we realize is that that distribution point will be coming from 1 meter because it's one company own this entire building, and then they will go to different panel boxes on different floors. All right, but if it's different companies, then we have to have different meters, and then we have risers going to the different floors to the panels. So down here we have this condition where we have our bus bar chamber and we have different meters and then different meters leading to the different floors, right? So it will be a combination of the two, right? And this is how we make our connection to our bus bar. And we will tell you about the lugs. And so these lugs, depending on the size of the current, may be crimped lugs or soldered lugs, right? So when we're talking about and we have different type of crimping tool. For high current capacity conductors, we're going to use a hydraulic crimping tool, which is totally different than the one where you're using your hand and crimp a 2.5 wire, right? The hydraulic crimping tool, it's for crimping bigger wires of bigger cross-sectional areas, right? So we're talking probably a 50 mm wire. You're going to use a hydraulic crimping tool and so forth. All right, this is us elaborating what to say about multi-story distribution, right? These cables are called risers, and the sub-main cables which run from, they are basically the sub-main cables which run from the individual points, right, and are carried up by laterals, right? So the laterals is what basically distribute horizontally, while the risers distribute vertically. So when we go to the floor, then we have to distribute laterally or horizontally, and those are called laterals, right? The majority of riser mains are in the form of bus bar trunking with either rectangular or circular conductors, right? This enables easy tapping of the sub-main, right? So what they are saying is that inside here, the bus bar would be either circular or rectangular. The rectangular ones are the ones that are mainly available because it's easy to connect your lugs to the rectangular type, right? That's what they're talking about. So we come to our lighting layout because we talk about getting power to the different sub-circuit. So now we have to talk about your distribution point now to your outlets. Now, one such consumption device is the lighting units, right? There are two main methods of wiring a lighting installation. One is through a ceiling rose or junction box, right? Is fed from the previous one in the form of a chain. So this is what we call a looping method. So we loop from one box to the next, right? So it's called a looping method, or you can feed from the supply to your individual points. But this is the one that is mainly used, right? So the main is brought into a central junction box, right? And then we go from that junction box to the different points, right? But again, this is the one that is mainly used because then we're talking about a large conduit in this type of installation, right? As well as the number of cables that can pull inside the conduit. Because if we're going to bring it to a point and then for every circuit, we're going to take it from this point, then we're talking about a larger conduit in the installation rather than loop from one box to the next. However, there are regulations that we must follow to tell you how much lights we can put on a particular circuit, right? And it all depends on the breaker that you are using, whether it be a 15 amp or a 20 amp breaker to control your light. In what is used as a standard is your 15 amp breaker to control your lights, right? So most of the time when you go into a panel and you see your 15 amp breaker, we're talking about your lighting circuits, right? When you see your 20 amp breakers, we're talking about like your plug circuits and so on. Now, for your power circuits or your plug circuits, we have two types of connection, right? We talk about your radial circuit connection. This is and you have your ring final circuit connection, right? You would have learned about these at some point for some persons when we talk about installation. So some persons will learn that the ring circuit, the advantage of the ring circuit is that it's fed from both ends, while the advantage, the radial circuit is fed from one end. So if there was a fault in the radial circuit, then the other connections after that fault point would not have any power. However, in a ring circuit, if there was a burn off, then there is a break, then all the circuits in the installation can be fed from both ends, all right? So look at this pictorially, right? We say a radial circuits are arranged so that each socket outlet is supplied via the previous one, right? So this also uses a looping method, right? And this is shown here. So we go from our live to our connection, then from our connection to another socket outlet, and then from that socket outlet to the next socket outlet and so on, right? So this is what we term as a radial circuit. And if the connection was to break here, then all the circuits beyond this point will not have any power, all right? So that's basically the disadvantage of a radial circuit. However, most installation would be wired like this, right? Rather than having a ring connection. The thing with the ring connection, we are talking about more conduits, right? To feed to a particular circuit, because it must be that both end of the stringer circuits must come back to your panel boxes, right? When we talk about our ring final circuit, we talk about both it's fed from both ends, right? So this is our ring final circuit. So at our distribution point, right, it is fed in this direction and it is fed in this direction, right? This is a more stable form of connection. So we're talking about like a sensitive area where you have computers and so forth, this type of circuit will be more beneficial than that of a radial circuit, right? And we can maximize the number of circuits that are placed on this type of connection, right? Just to elaborate that these are branch circuits from here is known as a spur, right? So for this type of installation, you can have spur circuits. It can be either non-fused or fused, right? In this case, we have like for your water heater circuit, you would have a switch outlet, and that switch outlet will control your water heater, right? That's one form of connecting these power circuits. All right, the mounting height of all of this that we talk about, right? So we talk about all this connection of power circuit, connection of lighting circuits, but how do we mount them and how do we determine that these are actually mounted in the right positions, right? So we're talking about for your maximum height of your switches, we're talking about 4 feet 6 inches or 1200 millimeter, right? The minimum height of your outlets above floor, we're talking about 18 inches or 450 millimeter, right? These should work out to the millimeter. We're talking about your surface, above your surfaces, right? So we're talking about to the top of should be 150 millimeter above work top, right? Which is you can work out. All right, so this is basically just a typical mounting heights. However, we're talking about from floor, we're talking about from the finished floor, right? So if you are doing a new installation, guys, you need to make allowance for your tiles, right? But what if they never put in the flooring before and you need to position your boxes and you need to do all of this, right? You need to take it as the, they would, on the diagram will indicate the floor, the height of the floor or the measurement of the floor, finished floor to the ceiling, right? So on your diagram, and this is why the diagram is elevation plan, it will show you what this distance should be, whether it be 9 feet or 10 feet, and hence you can measure from where your ceiling is going to be to your outlets, right, or your accessories. Now, if you don't know that, then you can actually take, and they have indicated the level, you can use your laser line, right? So rather than going around with a level and trying to catch the level right around, you use a laser line, and you catch a line, and then you can mark off your mounting height of your switches and outlets, all right? So you can do that. Now, water heaters. Water heaters, right, of the immersion type, such as the ones that are used in most residential and commercial settings, are available in several different forms, right? We said two of the more popular types are the 140 liter, right, and 1012 liter, right? Used for quantities of instant hot water, right? So these are the ones that we use in our home, the electric type. Both types are stationary appliances, so they are classified as stationary appliances, and as such should be treated in a certain aspect. All right, so it's recommended that heaters over 15 liters of their own circuit. All right, so we're talking about water heaters, and we're talking about capacity greater than 15 liters. They must have their own circuits, right? No, when we talk about own circuit, it means it must have on its single breaker and it must control only that water heater alone, right? So I'll give you an example of the type of connections that can be used for water heaters, right? So we have our panel box here. So this symbol is our panel box. We have our 2.5 mm cable. We have our 20 amp double pole switch. right? And then it's connected to our water heater here, right? If we were to connect two water heaters, we realize that we are using a larger breaker, right? We're using a larger cable, and we are able to connect two water heaters, right? But if we're talking a single water heater, then we're talking about 2.5, and this is below the 15 liter, right? So below 15 liters, we can connect them like this, right? So these are the typical arrangements that we'll use in our system. Now, why would we want to put two water heater on one breaker? It can be a case that we have two small water heaters supplying different sections of a building, right? And then in this case, rather than running separate cable, we actually buy a larger cable, and we are able to supply the two water heaters. All right, points to note, the heater shall be effectively connected to earth, meaning that the casing of the heater must be earth. The inlet and outlet pipes must be made of metal, so you cannot use PVC, right? And that is why when you go and look at an electric water heater, right where you make the connections to the water heater, they would have used a galvanized fitting, right? An earthing terminal must be provided, meaning that the water heater will have an earthing terminal where the connections are made. Heater must be supplied from a double pole link switch, not a plug-in or socket. So you can't go there. All right, your 220 outlet, that's what it is saying. You can't use a 220 socket outlet for a fixed appliance such as a water heater. It must be of a switch outlet type, right? A double pole link switch with you can either have a pilot light or it can be without a pilot light, right? So it doesn't matter if it has the pilot light or not. The pilot light is really for your benefit to know that when it's lit, there's power to the water heater. All right, so we talk about our space heating. We don't typically use space heating in Jamaica, but we have to look at it since we're talking about facilities and persons might get jobs overseas, right? So this is our typical configuration for a space heater. We're saying depending on the size of the space heater, the cable can be from 4 mm to 10 mm. So it can range from 4 mm to 10 mm depending on the capacity of the space heater, right? So this is for really warming cold spaces, right? And it's also connected to a double pole switch fuse, right? So this is how you turn your the supply onto the heater. Now, in today's society, a lot of these heaters will come with remote control to turn it on and off. So once the switch is on, you can use your remote control to turn the heater on or off and vary the temperature of the heater. All right. Commercial cookers, right? A cooker exceeding 3 kilowatts should be supplied on its own circuit, right? So we're not talking about your stove at home, but a commercial cooker that is above 3 kilowatts. As it is rare to have every heating element working at once, a diversity factor is applied to calculate the assumed current demand as follows, right? So we are saying that the first 10 amp of the total rated current of the connected cooking appliance plus 30% of the remainder of the total rated current of the connected appliance plus 5 amp if there is a socket outlet in the control. So what does all of this mean, right? So we say in doing this calculation, for example, the full load rating of our 230 volt cooker is supplied is 11.5 kilowatt, right? Calculating using the diversity factor, the assumed current demand, the cooker control unit as a socket outlet, actually full load demand, right? So this is what we will do. we will find the demand current. So we say the demand current of the device at full load is 50 amp, right? So applying the diversity factor, we would assume, remember we say the diversity factor is 30%, right? And so we find 30%, we subtract off the remainder. So we add 10%. So that is why we have 10 amp here. So we have 10 amp plus the remainder, 30% of the remainder. So this is finding 30% of 40 amp, right? And then add 5 more amps, right? And the total of that will be what our cooker will use to select our cable size, right? And we are getting 27 amps, so we're talking about using a 4 mm cable, right? So in this case, we cannot use the 2.5 millimeter cable. We definitely have to use a 4 millimeter cable. Now again, realize first 10 amp, right? Find 30% of the remainder, which is 30% of 40, and then add 5 amp if an outlet is being used, which it states that we must have an outlet, right? A switch outlet. Then we find our design current, which is 50 amp, right? And we know that at full load, this should be drawing 50 amp, right? So we say we'll find 10 amp, and then the remainder is 40 amp. We'll find 30% of that 40, add 5 amp to it, and then we end up with 27 amp. Now, what we are saying is that at most of the times, this appliance will be drawing 27 amps, right? So we, rather than sizing the cable for this 50 amp, which will be a very large cable compared to that of the 27 amp. So rather than using probably a 10 millimeter cable, we can use our 4 millimeter cable to run our commercial heater. All right, so that's really applying our diversity factor in this case. Points to note about our commercial cooker. If the assumed current demand of a cooker circuit exceed 15 amp, but does not exceed 50 amp, 2 or more cooking appliances may be fed if they are in the same room. So it means that if it's not over 15 amp, right, you can feed more than one appliance from that circuit. Every cooker must have a control switch within 2 meters, right? So we're talking about 6 feet. So within 6 feet of the cooker, you must have a switch that can switch it off. This is stated by regulation because of the heat, right, and for safety reasons, right? So you must have a quick means of isolating or turning the power off from reaching the cooking unit. If 2 cookers are installed, one switch may be used, provided that neither cooker is more than 2 meters from the switch, right? So it means that none of the cookers must be more than 6 feet from the switch. Very important. All right, alarm circuits. These types of system are usually supplied at extra low voltage, right? Rather than 110 or 220 volts, we're talking about 50 volts, so we're talking about the use of a transformer, right? Hence, these cannot be in the same conduit as the low voltage devices, right? So if we're using trunking, we have to use segregated trunking with different compartments. If we're using conduits, they must be drawn in, the conductors for these are cables, must be drawn in separate trunking conduits, right? So moving on, this is basically the diagram of a fire alarm circuit, the typical block diagram. So we have like our sensing devices such as your heat detector, your smoke detector, your break glass point, and we have the control panel, right? And we have the sounders, right? So any one of these sensors activated, then the control panel will sound, right? They can be so programmed that it give a local alarm or a non-local, right? An entire facility alarm, right? Such as the ones that are installed at UTEC, right? So we say there are two types of fire alarm circuits that you need to know about. The two type, we have the normally open and we have the normally closed. Now, the one shown here is a normally open, simple circuit. So we just show you a simple diagram, right? And based on the diagram that you are seeing here, right, we can just give a brief operation of the circuit, right? So any one of these devices that are activated, right, the alarm sounders will sound, right? So they are actually placed in parallel rather than in series. So in a normally closed situation, they are actually wired in series rather than parallel, right? So, which is this one now. So in the normally closed, realize that if you were to break any one of the circuit along any part here, right, the alarm will sound and it will go off. However, if you were able to isolate or bridge out one of these devices, then the alarm will not activate, right? So it's a tricky condition when we're talking about burglar or alarms and so forth. But this is a simple circuit and they are more complex than this. This is just showing you the different types of sensing arrangement, right? Points to note about fire alarm circuit. Each zone should not have a floor area in excess of 2,000 meters squared. Each zone should be confined to one story, meaning if it's a multi-story building, every floor should be considered a zone of protection, right? Except where the total floor area of the building does not exceed 300 meters. Staircases and very small buildings should be treated as one zone. So in a large building, the staircase is a zone, right? In a very small building or a one story building that is very small, a family dwelling is really one zone, right? Because typically you have those two entrances in most of these buildings, two doors, probably one main entrance and probably one fire. And normally the escape route is not labeled as an escape route. It's either your back door or the back door to the building and so forth, right? Each zone should be a single fire compartment. This means that the wall, ceiling, and floors are capable of containing the smoke and fire. It means that if you are putting a ceiling and there's a wall that separates them, the wall must continue to the roof of the building. It can't stop halfway in the building, right? You have to continue to the top of the building. All right, security alarm circuit. This is just one same thing as a fire alarm, similar type arrangement. You have an open circuit and you have a closed circuit, and they are showing you the different zones of control and how they are tied into your main panel. So this is your main terminals, and this is your sensing devices or your call points, right? And then we have a tamper-proof loop, right? So if you're able to isolate any one of these devices in a way, the tamper-proof loop, once it's cut, it will sound because then there's no continuity to the control, right? So you see it wired to one side inside the device, and then it completes apart and wired to the other terminal at the control station, right? Very effective when we're talking about security aspects. All right, finally but not least, we're talking about emergency lighting in buildings. We said these fall into two main categories, non-maintained and maintained, right? Both of these systems may be utilized by individual units or by centralized sources. What we mean by maintained and non-maintained? Now, this is our maintained system, right? In our maintained system, if you realize that our contacts A and B, right? This is our emergency light and this is our step-down transformer. What will happen if the step-down transformer is energized by your battery or charger or your JPS supply, right? So this is your battery charger and thing. You realize that your battery charger or your battery is connected to C and D, and these are normally closed contact, right? So when this have supply, these will be open, right? And if this is open, then there'll be no sound emergency light. However, if this is has no supply here, right, meaning this step-down transformer will not be energized, then this will open and then this contact will be closed. In the other situation where this is energized, these will be closed, right, and this will be closed. So in this one, at all time, there is power reaching the emergency contact, right, the emergency light. Now, in the non-maintained contact, right, system, there is the situation in that once light goes is when you actually want the emergency light to come in, right? So this is to our normal lights, and this is our emergency light, what we'll put up in the building, right? We have our contactor that is connected to our mains, and it's a normally closed contact. So once light goes, right, this will close and the emergency light will come on, right? This is our non-maintained system. Once there is no supply from JPS, what we realize is that this will open, says it, this will open and then it is not fed from the battery. However, in this non-maintained system, it's always good. There's always a test button on it for persons who are familiar with this type of device to test to see if the battery is actually operating, right? So what happens when you press the test device, it actually break one of the line here and it will now be supplied from the battery in its normally closed position. If you break it, I don't see any light, it means that either the charger not working, so the battery is not being charged, or the battery itself is defective and is unable to supply the emergency light. Right, so this is the one that we mainly use in emergency lighting. Once the light goes, then the light will come on. Once JPS goes, the light will come on and light the areas, right? It's very useful in terms of energy efficiency and saving the life of the bulb. Because remember, all bulbs, when we reach lighting, you realize that all bulbs have a finite working hours, right? So the bulb will not light forever. There is a number of operating hours that is associated with the light. And if you have the light on all the time, then you'll reach the operating hours or the switching life cycle very quickly. All right? The non-maintained light, here the lighting units remain de-energized until main failure occurs, at which time they are illuminated by a battery supply, right? The disadvantage with this type of installation is that broken lamps are not detected until they are called into operation. So this is what I'm saying, that this type of non-maintained light, after you have to go and service them regularly. So you have to have either your Monday checks or your monthly checks and so forth. But a lot of time when they install these lights, is only when light goes, you know that it's not working. And that's really the main disadvantage of this type of system. Right? So like over UTech, when light goes, a lot of time you might be walking in a dark corridor and say, boy, how the light not coming on? Because they have not been maintained, and a lot of time the batteries go and nobody changing. All right, so this will take us to our end of our lesson for today. All right. So thank you for listening. Again, guys, remember Monday. Thursday, 5 o'clock. I keep on of Monday. Your group is not, I don't have you on Monday. Thursday, 5 o'clock, we are going to be having our tutorial class, right? Our tutorial class will look at the calculations involved with the electrical system, right? So we'll be looking at the different types of, like your service entrance calculation, how to balance your electrical panels, and so on, how to calculate your earthing arrangement, and so on, right? How to calculate your overcurrent protection, that's your breakers. We'll be trying to cover all of those calculations in Thursday's class. All right?
All right, sir.
So please make it Thursday, 5 o'clock, right? We're trying to cover all of those so we can do our unit tests. All right, so the unit test, guys, it should be next week, but I am looking at actually next week during your tutorial time and not the lecture time, right? The tutorial time meaning the Thursday. Remember we said the tutorial after this kind of rough, you know? All right, so we're looking at next week Thursday for unit test, which will cover unit 1 and unit 2. All right. So our unit test will cover unit 1 and unit 2. And that is why I want to complete the calculations so you have enough time. I don't want it next week Tuesday. I don't have enough time to practice them if they're going to come on the test. All right.
Sir, what form is the test going to be?
Huh?
What form is the test going to be in?
Oh, it's going to be a multiple choice as well as probably short answer. So not straight multiple choice.
Sir, the PowerPoint, the PowerPoint presentation, how can we get that?
Moodle.
Moodle.
It's on Moodle. I put it on Moodle already.
All right, thanks.
This one is not on Moodle. I put it on Moodle by later, but the previous PowerPoints are on Moodle.
So the platform I'm going to get the test on. Which platform? Canvas?
Well, I have not decided yet. I know that some persons probably have problem with Moodle because in terms of that platform. So I need to decide. I'll let you know by next week's class which platform I'm going to use for Thursday, next week Thursday.
Okay.
All right. So if when I put out a message on persons have problem with Moodle, then I will see which other free platform out there or other platforms you can use so that to have everybody access the module. All right.
Yeah,
So
man.
remember, Thursday, 5 o'clock calculation. So nobody forget to know, as it might or might not come on your test next week. So you need to be at the calculation class so we can go through some calculations. All right?
All right.
All right, so next week, guys. Thursday, next week, Thursday. All right?
Yes.
All right, greetings. All right, boy.